Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 12.6, day 2, entitled The Binomial Theorem. And today we're going to talk more about expanding binomials. We're going to actually define the binomial theorem, and then we're going to actually use it to help us expand some very big binomials. So yesterday in the previous section of notes, we talked about Pascal's triangle and how we can use Pascal's triangle to come up with the coefficients in front of every term in the expanded binomials answer. And then we also talked about a shortcut with this notation here, where we have an n across the top of these parentheses, and then we've got 0, 1, 2, and so on until we get to that last value, which is our exponent. So that would be the same row in Pascal's triangle. So if this was a plus b to the fifth, this would be the fifth row of Pascal's triangle. And then we talked about how there's a decreasing and increasing patterns in our exponents. So this would be a to the fifth, and then the fourth, and then the third, and so on and so on. And then this would be b to the fifth, and then b to the fourth, and so on and so on and so on. So we go backwards. Okay? So when we put all those pieces together, this is what we get. This is our binomial theorem. So this is what we've already been working with. And now we'll use this as our two-piece shortcut to actually expand more complicated binomials. Now, just for our sanity, we're going to start with pretty low exponents here. So we'll have x plus y to the fourth and a minus b to the third. But here for part C, this is going to be to the fifth power. So that starts to get a little bit more complicated. And then we're also going to have numbers in front of the variables as well. So I have a 2x and a 3y. Now we haven't seen any yet where we have a subtraction. Here we have a minus b and then 2x minus 3y. So we're going to treat that negative, or that minus, as a negative that stays with the b, or a negative that stays with the 3y. So when that happens, we're going to have alternating signs in our final answer. Okay. But let's go back to part A here. We have x plus y to the fourth. So that means I'm in the fourth row of Pascal's triangle. So for my numbers in the parentheses here, I'm going to start with a 4, and then my first term will have 0. And then my x is going to be to the fourth power. And then I'll have 4 over 1. And then I'll have x to the third power, and then I get my y in there, my very first y. And then I'll have 4 and 2. And my x is going to decrease in the exponent. My y is going to increase. And then I'm going to have 4 and 3. So I'm almost done because I have to go up to 4. So I'll have x to the first now, and then y to the third. And then now I have 4 and 4. So that's my last term. Once these two are the same, then that's my last term. And then I'm not going to have any more x's. I've got x to the 0 and y to the fourth. Now remember, for those exponents, do that double check and make sure that they add up to your exponent here. So this is 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4. That's just a 4. Okay, so we got them all. We did it right. And then I've got 4s across the top row of the parentheses, and I've got 0, 1, 2, 3, 4 going across the bottom. So then you can go to your calculator, and you can evaluate this expression right there on your calculator. Remember, you're going to go to the math menu, and you're going to arrow over to probability, and you're going to use the option 3. So it's a C for a combination. So when you type it into your calculator, it's going to look like 4 and then C and then 0. So that's what it'll look like on your calculator. But when you evaluate that, you're going to get a 1. So we have 1x to the fourth. And then we have 4 over the 1, or 4 combination 1. That's going to be a 4, x to the third y. And then 4 combination 2, that's a 6, x squared, y squared. And then my pattern should repeat. So I should have the 4 again, x to the first, y to the third, and then I'll have a 1, y to the fourth. Okay, so that'll be my final answer then for my expanded binomial. It's going to be that polynomial with 5 terms in it. Okay, so let's try part B then. This is where we're going to have alternating signs because we've got a minus b. So we're going to think of this as like a plus a negative b to the third. So we're going to take that negative with the b. Okay. Now it's only to the third power, so not really focus so much on the numbers here as we are what happens with that alternating sign. And really we're on the third row of Pascal's triangle, so you could write out the first couple rows too and get these numbers. But I'm going to write it with our notation that we've been using. So I'm going to start with 3 and then 0. And then I want a to the third power, and I don't want any b's yet. And then I'll have 3 and a 1. And my a is going to decrease, and then my b is going to be a negative b to the first. And then I'm going to have 3 and 2. My a is going to decrease, and then my negative b is going to increase by an exponent. And then my last term here, I know it's my last term because I've got 3 and 3 here. And then I'm not going to have any a's. If I decreased again, I'd have a to the 0. So I'll have negative b to the third. Now you know that anytime you take a negative number to an odd powered exponent, you get a negative answer. When you have a negative number and you take it to an even powered exponent, you get a positive. So this is how we're going to get our alternating signs. Okay, so the 3 combination 0 is going to be a 1, a to the third. 3 combination 1 is going to be a 3. And then I'm going to have a squared. But here I've got negative b to the first. So I'm really going to have negative 3 a squared b to the first. So if this ends up being a negative value, I'm just going to bring that negative out front. It's kind of like taking that negative 1 and multiplying it by the positive 3. I get the negative 3 or the minus 3. Okay, my next term is going to be a 3 as well. And then I'll have a to the first, and then here I'll get a positive b squared. So I go back to my plus 3ab squared. And now here I should get another minus. Okay, negative b to the third power, that's going to be a negative. It's going to like be a negative 1, and 3 combination 3 is a 1. So negative 1 times 1, that's a negative 1. So I have a minus 1b to the third. Okay. So only 4 terms here. Remember, you get one more term than your power in your, or that your binomial is being expanded to. So here my exponent was a 3 and I have 4 terms. Here my exponent was a 4 and I had 5 terms. So that's another way to double check, make sure that you have all of the correct parts of your answer. Okay. Now part C, we're going to see our signs alternating again, but we're also going to get bigger numbers here. Okay, we're going to have to take the 2 to the fourth power and the third power and so on. We're going to have to take the negative 3 to the fifth power, fourth power, third power, and so on. Okay, so those numbers are going to go with our terms that go with our variables. Okay. So that 2 is going to stay with the x, and the 3 is going to, then negative 3 is going to stay with the y. So again, we're going to think of this as like a 2x plus a negative 3y. Okay. So those numbers don't affect what goes in our parentheses here. The only thing that goes in the parentheses for this notation for the coefficients is just this exponent that we're dealing with. So I'm still going to have 5 across the top for all of those little parentheses. And then I'm going to have 0, 1, 2, 3, 4, 5 across the bottom. So this is still going to be just the fifth row of Pascal's triangle. Again, not super duper challenging. You could write out the first 5 rows if you wanted to and find the coefficients that way. But I'm just going to use the notation we've been practicing. Okay. And this one's going to get a little complicated. It might get a little smushy here. So I'll try and be conservative with my space. But I'm going to start with 5, 0. And then I'll have my first term is the 2x to the fifth. And then I'll have my 5, 1. And then I'll have my 2x to the fourth. But now I've got to bring in that negative 3y. So negative 3y to the first power. right? So you can see already how it gets complicated here. We've got a lot of stuff to write. So I have 5 over 2 then, and then I'll have the 2x to the third power. That's going to decrease, and then the negative 3y to the second power. So once you get the first few terms written, then you can just kind of look back at your previous step to adjust your exponents. All right, then I'm going to have my 5 over 3, and then I'll have a 2x squared. Let's see if I can go off to the edge here a little bit. And then I'll have a negative 3y to the third. And then I'm going to have a 5, 4. Whoops, that's a 4. And then I'll have my 2x to the first power, and then the negative 3y. Oh, it's going to shrink for me. Okay, negative 3y to the fourth. Okay, let's see if I can clean up that edge there. Okay, 3y parentheses to the fourth. Okay, let me write the next one underneath it then. Then I'll have a 5, 5. I don't have my 2x, but I have the negative 3y now to the fifth. Okay, so a lot of terms. So definitely use your paper when you're doing this. When you expand this, it's going to take up your whole paper going all the way across. Okay. So now the tricky part is we have to evaluate these numbers for the combinations, and then we have to do 2 to the fifth power. And here we're going to have to do 2 to the fourth power, and then negative 3 to the first power. So we're going to get a lot of numbers here. So let me start over here a little bit more. So 5 combination 0, that's going to be a 1. Okay, 2 to the fifth power, that's 32, and then I have x to the fifth. And then 5 to the first, or I'm sorry, 5 combination 1, that's going to be a 5, so I'll have plus 5. Okay, 2 to the fourth power, that's going to be 16, x to the fourth. And then I've got my negative 3 to the first, so that's negative 3. So I'm going to put times negative 3y. So eventually this will be one whole term here. And then 5 combination 2, that's a 10. And then 2 to the third, that's 8, x to the third. And then I've also got negative 3 squared, so that's 9y squared. So again, that's positive now. Okay. So let's see, now I'm on my 5 combination 3. So that's going to be another 10. And then 2 squared is 4, x squared. And then negative 3 to the third, that's a negative 27, y to the third. 5 over 4. Now notice here I had a 10 and then a 10, so I should be going back to the 5. So 5 over 4, 5 combination 4, that's going to be a 5. And then I just have my 2x. But now I have negative 3 to the fourth, so that's going to be a positive again. And negative 3 to the fourth, that's 81. So positive 81 y to the fourth. Let's see if I can get my last term in here. 5 over 5, 5 combination 5, that's a 1. I don't have my x term. And now here again, I'm going to get a negative number because I have negative 3 to an odd power. So negative 3 to the fifth power, that's 243. So negative 243 y to the fifth. Okay, so now if you need to, you can do a little color coding or you can underline. Oops. So this is one whole term. This is one whole term. This is another whole term. So you got to remember you've got your x and then your number and your y. Sometimes students kind of get lost when they're writing this all out. They lose their terms or they start multiplying, combining, and adding inappropriately. Okay, so final answer then here is going to be 32x to the fifth. Now here I have to take 5 times 16 times negative 3. So that's a negative 240. And then I'll have x to the fourth y. Then I'm going to have 10 times 8, so that's 80, times 9 would be 720, so I'll have positive 720, x to the third y squared. So notice how I've gone from a positive to a negative to a positive. Now my next term should be negative. So here I've got 10 times 4, which is 40, times the negative 72, so that's going to be a negative 1080 x squared y. Now I should go back to positive, so 5 times 2 is 10 times 81, that's going to be 810 xy to the fourth. Then my last term should be a negative 243 y to the fifth. So once you get your final answer way down here at the bottom of the screen, I know that's maybe a little hard to see with the red and the gray there, but once you get down to the bottom of the screen and you can see this final answer, it's really not so terrible. It gets kind of messy in that first step when you're writing everything out, and it gets super messy in the middle because you've got a lot of terms that you're dealing with. You've got a number for that parenthesis notation for the leading coefficient in each binomial term, and then you've got numbers that you're raising to the fifth power or to the fourth power, or you're cubing and squaring. So there's a lot of different numbers in here. So just take it one term at a time. Even if you want to write it out one term at a time, write out your big expression and then simplify this and get the 1 times 32x to the fifth and then write 32x to the fifth down below. And you can simplify it one term at a time. Okay? So definitely practice that because it's just a lot of detail. It's not challenging stuff, it's just a lot of detail. Okay? So the last thing we're going to talk about then is how we can find a specific term using the binomial theorem. And this is kind of cool. It's kind of a shortcut. Okay? So you have to pay attention though to what the numbers are. Here we have n for the actual number that we're dealing with, the exponent. The power that we're dealing with, I guess I should say. And then we have a, and then we have b. Now they're raising a to the power of r. So r is kind of like that very first exponent, or it could be that term that you want or that you're trying to find. So let's see. Then b is going to be raised to the n minus r power. So it kind of depends if they tell you that you want to find a specific term or if you want to find an exponent with a specific power. It kind of depends on the situation as to what that n and r is representing. But n is always going to be your original power from the binomial, and then r could be a certain exponent in a certain number of terms, or that certain exponent in a certain term in your expansion. Okay, so let's take a look here at our last two examples. And as we go through this, it'll make a little bit more sense as to what each part is. Okay, so for part A, we're going to find the term that contains x to the fifth in the expansion of 2x plus y to the 20th. Okay, so we want to have x to the fifth. So that means if I look at, or if I even rewrite it here, I've got n, and then n minus r, then I'll have a to the r, and then b, n minus r. So I want to have x to the fifth. That's what I want, and x is my first term here, and I want it to be to the fifth power. So that means my r value is going to be 5. So in this case, r is that specific exponent that you want. And then that's going to help me figure out n and n minus r. Now, n is always going to be the power here, so n is going to be 20. Okay, so then I can do n minus r. Okay, so n is going to be 20, n minus r is going to be 15, so that helps me come up with that lead coefficient. And then I want x to be to the fifth power, but I also have to take the 2 with it. So I want 2x to the fifth power. That's my first term. And then my second term is y. It's a positive y because I'm adding in between here. And then I'll want y to be to the n minus r as well, so that's going to be to the 15th. Now that should make sense if you wanted to draw like little spaces or little dashes and say, okay, my first term would be x to the 20th, and then 19, 18, 17, 16, 15. You could count all the way out and kind of work your way backwards too and say, okay, if x is to the fifth power, then remember these have to add up to 20, so this obviously has to be 15. So you could kind of think through it visually if you wanted to write all those little spaces out. And now they want to erase. Or you can just use the formula. I can't get those to erase. Okay, so we'll just ignore them. So now 20 combination 15, that's going to be a big number. 15,504 times 2 to the 5th power, that's 32, and then x to the 5th, and then I have y to the 15th. Thank goodness I don't have a number there. So now I'm going to take the 15,504, multiply it by 32, so I'm going to get 496,128. Yikes. X to the 5th, y to the 15th. Okay? So I can use our knowledge of Pascal's triangle and the binomial theorem so that I can actually find a specific term without having to do the entire expansion. And that's kind of cool. Okay, last example then. We're going to find the 7th term now. Okay, so this one I think is good to think of the little dashes because we're only going 7 terms in. The other one was a little bit more challenging. We ended up needing, the 15th term. But here we're only going 7 terms in. So 1, 2, 3, 4, 5, 6, 7. And this is kind of what I was referring to up here where I was talking about making these little dashes. So I know my first term is going to be to the 20th, and then 19, 18, 17, 16, 15, 14. Okay, so if I'm dealing with the 7th term, I'm going to have x to the 14th power. So that tells me my r value is going to be 14. N is always going to be that power that they give you on the binomial, so that's 20. Okay, so now I have all the information that I need to start plugging it into our formula over here. This little one right there. Oops, that actually wasn't part of our formula. So I'm going to have 20 again, and I'm going to do n minus r, so that's going to be 6. So I'm going to have 20 combination 6. And then I want 2x to be to the 14th power this time, so that's going to be a big number. And then I'm going to have y, and this will be to the 6th power because 14 plus 6 has to equal 20. Okay, so notice that our binomial expansion was the same here for both of these examples. Okay, so this is one where you're trying to find a specific exponent. Here you're trying to find a specific term. So you're going to see both of these types of examples in your homework. So now we just do 20 combination 6. So do that on your calculator. That's going to be 38,760. And then 2 to the 14th power, that's going to be 16,384. And then we'll have x to the 14th and y to the 6th. So when I multiply those numbers together, yikes, another big number, 635,043,840 x to the 14th, y to the 6th. So again, this is why we're not doing the 20th row of Pascal's triangle, okay? Because our lead coefficient there is the 38,000, and then we have to take 2 to the 14th power, so we get another 16,000 in there. So we're getting huge numbers, okay? So hopefully you won't have any that huge in your homework where you have to expand it all out. But if you do, it's okay. Don't be afraid of the big numbers. So these last 2 examples, these are just a really cool application and a shortcut for how we can use and interpret the binomial theorem and how we can find a specific term. So again, lots of little details, but remember you have your formula sheet, so practice this homework, check answers in the back of the book. The solutions are worked out on the class website, and I have it all written out so you can see every single step. And if you have any questions, come on in and see me before school.